All right, let's just jump right in. The title of this explainer, it sounds like a total contradiction, doesn't it? Ultra clean and coal plant. You just don't expect to hear those words together. But believe it or not, the technology to make it happen is real, and we're going to break down exactly how it works. So, check this out. If you had to guess, you'd probably say this is some new tech company headquarters, right? Maybe somewhere in Silicon Valley. It's so sleek, so modern. But no, what you're actually looking at is a coal-fired power plant. And this single image really sets the stage for one heck of an engineering challenge. And that really brings us to the million-dollar question. Is it even possible? Can a power source that we all, associate with smoke and pollution, can it actually be engineered to be, well, clean? Let's dig in and find out. Okay, so to understand this, our story kicks off in a city called Semey in Kazakhstan. This isn't just a thought experiment, it's a place where a real-world problem led to this incredible engineering paradox. Here's the deal. The city of Semey desperately needs reliable power. And not just for lights, it gets seriously cold there, so they need it for district heating, to keep homes warm all winter. Now, the obvious fuel choice is coal. It's local, it's reliable. But here's the twist. The government basically drew a line in the sand. They said, sure, build a new plant, but it has to meet some of the strictest environmental standards on the planet. We're talking European-level strict. And I'm not kidding when I say strict. Just look at these numbers. The limits they had to hit for dust, for sulfur dioxide, for nitrogen oxides. They are literally the same as the European Union's directive. That's a high bar. But then you get to wastewater and, wow, zero. As in zero liquid discharge. Not a single drop of industrial wastewater can leave the site. That is, without a doubt, one of the toughest environmental standards you'll find anywhere. So how do you even begin to meet targets like that? Well, you have to take the flue gas. That's just the hot exhaust that comes from burning the coal. And you have to force it through this intense multi-stage cleaning process. The best way to think about it is like an industrial gauntlet. All right, this diagram here, this is going to be our roadmap for the next few minutes. We're going to follow the journey of that hot, dirty gas. It starts at the boiler, and then it winds its way through this whole series of massive cleaning machines. Each one is designed to strip out a specific pollutant, one after another, until what's left is finally clean enough to go up the stack and out into the air. So let's break this whole journey down into 4 key steps. Simple enough, right? First, we've got to capture the dust, all those tiny solid particles. Second, we have to scrub out the sulfur. That's the stuff that causes acid rain. Third, we need to neutralize the nitrogen oxides that create smog. And then there's a really clever final step that makes sure what comes out of the stack is totally clean and, well, invisible. Let's get into it. All right, time to get into the nitty-gritty, the actual heavy machinery. The first big job is to deal with what are called the big 3 air pollutants. That's dust, sulfur, and what we call NOx, or nitrogen oxides. So first on the list is dust, also known as fly ash. And to catch it, you basically got 2 main choices. On one hand, you have the electrostatic precipitator, or ESP. You can think of it like a giant magnet for dust. It uses a powerful static charge to literally pull the ash particles right out of the air. The other option is a fabric filter, which is pretty much what it sounds like, a giant industrial-scale vacuum cleaner that forces the gas through these enormous filter bags. For this particular plant in Semey, they went with the ESP. Why? Well, it's a well-known, proven technology in that part of the world, and it's a bit more cost-effective. And get this, the performance is just incredible. A well-designed ESP can pull out more than 99.9% of all the dust and ash. Think about that. Almost every single solid particle is captured. So, boom, first major hurdle cleared. Okay, so catching solids, that makes sense, right? You can filter them, you can zap them with static. But the next thing on our list, sulfur dioxide, that's a gas. So how in the world do you catch a gas that's mixed in with a bunch of other gases? You can't just run it through a filter. Well, the answer is kind of surprising. You wash it. It's that simple. This enormous tower you see here, it's basically a giant industrial shower. They pumped the dirty gas up from the bottom, and at the same time, a constant rain of limestone mixed with water, they call it a slurry, showers down from the top. As they mix, a chemical reaction happens that literally grabs the sulfur dioxide right out of the gas. And this chart just shows you how incredibly effective that is. Look at the bar on the left. That's the gas going in, loaded with up to 1,800 milligrams of sulfur dioxide. Now look at the bar on the right. That's what comes out, less than 75. It's a reduction of over 96%, just gone. and that easily smashes the target they needed to hit. But, and this is a big but, all of this cleaning isn't free. It takes a ton of energy. You've got these massive pumps that are constantly moving that limestone slurry around, and giant blowers forcing air into the system. All that machinery working together can actually eat up around 2.5% of the entire power plant's output. It's a great reminder. Cleaning power takes power. Okay, so that brings us to the last of the big three pollutants, nitrogen oxides, or NOx. The game plan for NOx is a 1-2 punch. The first and most important move is to stop it from being created in the first place. They do that by using special low NOx burners right inside the boiler. That handles most of it. But if they need to get the levels even lower, they can add a second system that works almost exactly like the catalytic converter in your car, neutralizing whatever's left. So there you have it. We've dealt with the big three air pollutants. But we're not done yet. To earn that ultra-clean title, you have to do more. You've got to close the loop on everything, and that means dealing with every single waste stream, especially the water. Okay, remember how we washed the gas to get the sulfur out? Well, after that shower, the gas is clean, sure, but it's also cold and totally saturated with water. If you just let that go out the smokestack, you'd see this giant white cloud of steam. To avoid that, they use this really clever piece of equipment that basically recycles heat. It takes heat from the hot, dirty gas coming in and uses it to warm up the clean, wet gas going out. The result? The plume becomes invisible, and as a bonus, it protects the steel smokestack from rusting from the inside out. Now let's talk about the water. Remember that crazy strict rule? The one that said 0 liquid discharge? This is what that actually means. It's more than just a piece of tech, it's a whole philosophy. The goal is to make sure not one drop of wastewater ever leaves the plant. You treat it, you purify it, you reuse the clean water, and the only thing left over is a completely dry, solid waste. The actual process is, super complex, but we can boil it down to 4 main stages. First, you just collect all the wastewater from everywhere in the plant into one big basin. Then, you use chemical reactions to get the solids and heavy metals to drop out. Step 3 is the high-tech part. You use these advanced filters, like reverse osmosis, to squeeze pure H2O out, leaving behind a really concentrated salty brine. And for the final step, you take that brine and you basically cook it until all the water evaporates, and all you have left is a dry, solid salt that you can safely dispose of. So what's the payoff for all that work? Well, just look at this chart. That whole complicated ZLD system allows the plant to recover and reuse about 85% of its wastewater. It's basically a massive water recycling facility built right into the power plant itself. And I think this quote from the engineers really says it all. The only water the plant actually uses up is the water that evaporates from the cooling towers or gets sent out to the city as steam for heating. Every other drop of water inside the plant just gets recycled indefinitely. It's a closed loop. So, let's circle all the way back to where we started. Can you actually build a clean coal plant? Well, from a purely technological standpoint, the answer seems to be, yeah, you can. It's absolutely possible to engineer these incredibly complex systems to capture more than 99% of the pollutants and recycle almost all of the water. But, and it's a huge but, it takes an enormous amount of extra machinery, it consumes a significant amount of energy, and it costs a lot of money just to clean up the mess from the initial combustion. And that really leaves us with one last big question to think about. What does the immense effort and expense of making a dirty fuel clean really tell us about our energy future?